So yeah, without further ado, here's me. I'm one Jimmy. I'm a senior technical artist, environment. For people who aren't used to the game industry, you might see technical artists and they're all the same. No, I do not actually work with animations, and I do not do rigs. Though I have played with them, and they're pretty fun. There's a little bit of a process to get to this point, though. I've been a technical artist, I've been an environment artist, I've been a world builder, I've been an intern. It's a long road in this industry. I'm getting close to 7 years in professionally, but there's a lot of places that I dealt with before going there. I actually started off at A&M trying to do the Viz program, and while they're great, love it, I'm not a calculus nut. So I transferred over and did the UT Dallas art technology program, graduated from there, got an internship out of there with abstract, and realized that I needed to level up. This is a hard industry that you need to actually, really show up with your game face on. So after a summer in Houston, working in an unair-conditioned warehouse, building servers, I eventually got my portfolio accepted in Millman. While I absolutely love Millman, everybody should love Millman, but at the same time, it doesn't matter. This is anybody that's listening to this that needs to hear this. Like, you can learn how to build a video game from YouTube. You don't need to pay for a fancy school. You need drive. You need to be committed to it, show up, spend the time. So some other studios I worked at in Dreamscape was a VR company that there's incredibly fun Disney Imagineers doing in-person VR experiences, Visionary Realms, Pantheon, Rise of the Fallen, and MMO. And now I'm at Singularity 6, which was recently bought by Dingo. And I had seen something on MMORPG.com or something a while ago, but I hadn't really been paying attention. It's a really fun world to be in. The game is built to be comfy and cozy. It's intending for you to just chill whenever you're in. There's no threat of life. Coming from Pantheon, incredibly hardcore MMO, it's a little bit different for me. But that's great. I actually had I have a couple of, the privilege of owning a couple different things at this company. I'm a tech artist, but I'm also kind of an environment artist. And so, I've been given the opportunity to own the housing system, own the foliage, own the grass, to own the cliffs. I also regularly work with logs, imposters, collision, mathmet, forward partition, and streaming. Those are basically the same thing, but depending on which platform, it can actually mean completely different things. Logs, by the way, are level of detail. So whenever there's a mesh that might be incredibly beautiful up close, we need it to look like a potato at a distance. So that's a thing. Imposters are a fake image of something to represent it. Collision might make sense. Nav mesh is what the non-player characters utilize to walk around the world, and then the other two will occur into its fun. We're going to dive into the housing system now, and we're going to start with a high-level overview. I actually completely rearranged how these slides were based on some feedback I got, so hopefully it makes more sense or it's not less confusing, but let's do it. So this is kind of what the player can do. This is from the player's perspective of how you can manipulate the housing system. We've got several different room sizes, a large, a medium, a small, and a hallway. Those can all pretty much connect to each other in any form of fashion, and they're very intentionally not limiting what the player can do. One of the things, one of the hallmarks of this company and this game is to give the players the ability to express themselves. And so throughout all the different game systems, we're trying to get them flexibility. So there were a couple challenges with this system. If you're familiar with Unreal, then you might know that there's dynamic Booleaning, which is really, really cool, but also kind of scary to utilize on a Switch maybe. if your team has never used that new feature before. So we had to lean into stuff that we know that we could ship, but we certainly are interested in the more dynamic opportunities. We also have a lot of different wallpapers and customization that happens on these. You need specific collision for them, specific lawns. But anyways, let's dive in. So here's kind of what the kit looks like in its current amount. There's more pieces than this, but it's a pretty good representation of the different size rooms and how they stack up. You might note there's a lot of rooms. Rooms are kind of hard when you have different, I forgot what it's called, different angles of the pitch. Thank you. So let's break it down. This is what a typical house might start with, but we're not going to have a typical house, and today we're just going to focus on one wall of that house. I'm not going to try and go through the whole thing, but we're going to try and focus on a wall. A wall has two different sides, an internal side, the side B, and then the external side, side A. And those have different material indexes that are applied to them. What a material index is really is just an association with a set of textures that happens to be different than the other sets of textures applied to a mesh. So if you have multiple material indexes, you could have multiple things shown on the mesh in a pretty easy way. For our focuses, due to the way that our blueprints and the programming was configured, we needed specific material indexes, not other ways of packing it. We're not talking about like first packing material layers. We need straight up a material index. And so this is the problem that we're trying to solve, is to make sure that those are separated and understandable, as we make them the mesh. So here's the house with the small room attached to it. But the reality of the house is that it's actually going to get a lot more customized than that. You're going to have wallpapers. Those wallpapers can be different. And you're going to have potentially different wallpapers on the inside of the house that might be customized, completely different. And then maybe in the other room, there's also materials, and, it can kind of get a little bit crazy really quick. When your game designer is saying, hey, I want to customize the wallpapers in all the rooms. Well, that could be a larger problem to solve. If we were to remove that building, the left room, it actually looks like this. If we think back to the wall that was there, we're not actually doing a Boolean operation right here. We're just swapping the mesh to something that fits having that exact room with it. And so if we zoom in on it, it's got something that fits exactly the size of that room. And then there's a beam, if you remember, that overlapped that seam. So we're actually hiding our seams pretty well. It might look messy, but for all could. Let's dive into this and think through how something like this could work. For this example, I'm just going to show you how we might cut out this interior portion. So again, sorry, I jumped ahead. That's what the other side looks like. It's got its own material on it because, why not? So there's 3 different wallpaper controls for this one wall right now, in addition to the trim textures that are being applied in various places. We've got, these are the actual terms that we use internally for them. So there's pattern 0 is the internal face that's always there. We've got the exterior one. You can always trust that there's an exterior. And then potentially we have a pattern 1 depending on the wall. And so this is kind of how we would go about it from a high level perspective, is we take a basic wall, we select our subtraction piece, we size it to the correct size. So that, if that was confusing, I actually take that 7, the smaller wall, and I use an intersection Boolean, which means whatever is intersecting with that key, we're going to keep. And so here we're keeping only that center portion, then we're going to chop out that part, add in our trim, and then you're good to go on the snake eye. Now, if we wanted to add in the other pieces, we would take an exterior wall. We would then choose our size cutting mesh, be the 7, chop that out, and then merge them back together. And here we go. I actually want to point out, I messed this up. This in the actual cutting, it only extends halfway through this wall. And that gives us a solid wall pattern 0 on the other side that does not break the scene. Bad example, but at least I pointed it out. Anyways, let's dig into Houdini. It's going to get kind of confusing now. And we'll have a Q&A after this part too, so just, it'll be fine. With any project, you have to set your project settings, and this is just like that. For this example, we set our building type, so we're defining it as harvest, and the name of these meshes are all going to have harvest as a part of it because it's the harvest house. There's an intention to have many different types of houses, and so we built a pipeline that could take lots of different types of meshes. This is a string that's referenced for file naming export later on and mesh grabbing. So I'm going to point out this right here. This is our file input. We're looking at this node. This is the normal Houdini editor, and when there's that little blue thing right there, that means that's what we have focused on. That's what we're tree dealer. Up here, I'm just kind of trying to explain to y'all with this image that we're saying this is my project location. I'm looking inside the input folder as in input meshes for the house. I'm referencing the detail of what set name it is. That was Parbase that you just saw. And then I'm going to grab the node name, which is wall inner 11 FDX. So we're just referencing this, and it's just an easier way. This allows us to move through different types of meshes. Any mesh that I get, I've got a lot of different inputs coming in. They could be from Max, they could be from Blender. I don't know what's coming in necessarily. So I'm going to clean up the meshes. I do this for all of them. If I don't need the input, then I'm going to chop it out. So all of these variables I'm removing from the mesh that comes there. I kind of jumped through this on this. I'm going to explain this for a second. We've got a for loop right here. And the way this for loop is configured, come on ahead. All good. Sure. The way this for loop is configured, I found that in Booleaning things in Houdini, it's better to go by connectivity through a for loop as opposed to doing a Boolean just straight up on the mesh. You get better geometry because we're chopping it individually. You'll note that there's like 24 pieces in here. That's a lot of floating geometry that could cause problems. I'm taking the room 7, so I'm using that smaller ring size, and we're doing the intersection operation right here. And then I'm going to use this wall. Usually in Houdini, it's a common thing to use a null node that has like an out or something like that. I can now reference this wall hound for anything else. We're going to go ahead and start chopping that. Here's my chopping mesh, and just to walk the grass, we've got the specific door double 0-1 hole, because there could be 0-2 of that door double. We're grabbing 0-1. It's got all of that weird naming conventions that I had earlier, so we know exactly the one that it's got that's coming in. It's being cleaned the same way I showed you before, but this time I've added in this apply material. This is basically just naturally wrangle, but what we're doing is making sure that there's not a material index that is different than what we currently are having. This could potentially, if we didn't do this, add another material index to the output of the mesh. So just making sure I'm getting the right thing. We then chop it, and then we merge in our frame. This is just a trim piece that was pre-modeled. We're just merging it in. It's not a big deal. And we're making sure that it has the proper material for it as well. Due to the way that we output, we might have like 5 different versions of this wall. There was a time, you'll see a GIF later of it, but I moved the doors where a wall might have a door located on the left or on the right. And so we had a neat naming convention where you would add in, this is the 3rd version of that. From here, we're basically done. It's just cleaning it up at this point. I'm going to merge in all the different walls. So you see the single door, you see the full wall as well. Those are just all the different meshes. We applied vertex color. We're going black on it because we don't want to have some strange blending that happens on our shader if you have vertex color already applied. So it's going to go black. Can't really see what it's doing, but that's fine. Then we're going to for loop out our output from these meshes. Don't really worry about what you're looking at here. There's a way to do this now in Houdini and for some time I might add, where you would probably make this a TOPS network, which is a different way of working in Houdini, but it allows you to output different versions of a file very easily. If I were ever to remake this, I would do a TOPS network for it, and that would be the way to do it. But I came into this project with a little bit of legacy effort, like legacy stuff, and if it works, it works. That's okay. I got to get my job done. I'll also point out this is how I'm outputting it. So I'm grabbing a specific folder. I'm adding in SM. I'm adding in the set name of Harvest. And then I've got the wall inner. And then we add in the channel of the piece name. So that one that we saw earlier would be piece 3. And then it'd be .fbx. And this for loop will just iterate over all the input meshes that are on it and what good to go. That was a lot. That was pretty scary, but we're almost done. This is kind of what our input meshes folder looks like. And this is what our output meshes folder looks like. We process things, even if they're primarily handmade, we'll still process them in Houdini for continuity and control. I can't tell you how many times I've benefited from the network already being set up and being able to grab that one thing and manipulate it slightly and then export it again. Procedural workflows are the what? Whatever. I'm going to keep going if you let me. So this is showcasing some of the stuff that we didn't necessarily ship. There were a lot of other variants of this that were a lot more complicated that we ended up not using because while we're a game that's on Switch, we need a very small package size. We need not a lot of meshes. We need the meshes that we have to, pay the bills. We need cosmetics to be the brunt of our assets. And so we ended up going with, all right, I'll take that away. We ended up going with just being on the center of each wall. The intention is eventually to get more. And it's set up in every single wall in every single building for that, which is nice. But so again, here's kind of using that same pipeline that we just looked at. It's much more spiderwebby in the non-example version, but it's just exactly what you saw applied to more meshes. I'm going to move on. All right, so we're going to talk about auto topology. This is actually a fun thing that I got to work on for a new level that we were developing at the time. It's the Earth Temple. This was basically our game designer and art director were like, hey, we want a destructible wall, and we don't know what's going to look like. Can you create something that'll procedurally make walls and then destroy them? Can you make something sculpted that we can then chop out? We want to specifically use the chaos dynamic system and see how that goes, because we might want to use this in the future. And so that was kind of the problem statement for this. So let's dig in. Like I said, accept any type of mesh input, within reason. This is we're trying to break down a wall in this instance. So something that's thin, something that's contiguous. We're going to try and hit the poly count we need. So, it was a game res object. It's not a movie. We need to lower that thing down. We need our UV scales to fit the tilers of the walls that we're applying it to. So we might need controls to change the scale of the UVs. And then we've got to apply the correct materials to them. So this is the end result. It was through, a team effort. I had VFX artists working with me on this, but effectively I did the breaking mesh pieces and the added in dust and all sorts of fun Niagara stuff. but that's kind of the end result. And so let's kind of dive in and see where it was at. The end result was a sculpted mesh from ZBrush that we then processed. Both the exterior portion of the mesh and the interior that breaks were sculpted and processed in Houdini. I'm going to walk through this graph, but I just wanted to show you all what it was. That little chopping part at the end, that's chaos, chopping it up. And a cool thing about that, this is what that gets crazy to look at for too long. A cool thing about the chopping of chaos is that it's very dynamic. I got to do like 8 versions of every iteration of this. This was like the 4th version of this wall. Each one of them was really fun. I recommend chaos, but it can have some cache issues. It can be some finicky stuff. But let's dive in. This is going to be a little bit less strict in our file naming and in our organization of the graph in comparison to the Houdini, in comparison to the housing. So we're just inputting in our mesh. I'm going to turn it into a VDB. Something that's, a very common thing for Houdini users is to make a rock generator. This is kind of one of the main steps that you do when you're trying to make a rock generator, at least maybe at the end, once you've kind of got a shape similar to it. I'm going to convert that VDB. By the way, a VDB is a volume. That's why I'm doing it. I'm trying to make this thing not have interior faces that could cause problems later on. I'm making it one mesh. I convert that mesh back to polygonal geometry from there, and then we start reducing it. Something that some teacher taught me a long time ago was don't reduce all in one go. None of the software ever handles it very well. Do it in phases. Chop it down to be something smaller, chop it again, heck, chop it one more time, why not? And see if it works. Hey, at this point in this, I didn't really explain it very well in the slides, but I take geometry, I group geometry by that which is facing forward and that which is facing backwards, and I apply logic to it. And then I take geometry that's facing inward or facing, left and right or up and down, and that gets its own grouping. I'm viewing these things as this is the contiguous wall that I want to look like the other walls. And then the interior stuff, I'm going to apply a different tiler to that looks like it's destroyed. So here we are with the front-facing and back-facing geometry. There's then a UV unwrap it, where we might scale it. And now here's the interior geometry. And I'm going to do the same, where I'm unwrapping it and I'm scaling those UVs. If you can see here on the bottom right, this might be hard to see in the back, but we have different scaling applied to these, just because that's what the tilers were in the engine. Sometimes you have to mess with textile density a little bit, a smidge. It's a stylized game, come on. And that's really it. Like, I ran the whole mesh through that one little pipeline, and it did everything that I needed. It was just converting it to a volume, processing it down to be something usable, UVing it into something relatable, merging it together. By the way, I want to point out that the fuse node is basically your merge vertex node for other things. Use the fuse node. It's like a safety, like in Unreal or in Maya, I always like spam freeze transformations, delete all history, merge verts, like fuse. So yeah. And then I throw in a clean at the bottom of that. There's some other stuff that you can do. Below this, I have manual outputs of this going into manual nodes that I am up with. So not really worth diving into, but this is the kind of the pipeline. And what's cool about it is I can totally reuse this for other levels. I'm just grabbing the exact same stuff and changing the file input at the top, changing the output name at the bottom. This is a graph that I can actually build on for the future. It's fun. Yeah. Bling. We're going to move on to the foliage converter. My favorite, Foliage. I'm a big Foliage guy. You can catch me just sculpting a leaf in my free time. I'm a Foliage guy. this project has been going on. I'm not sure if it's 6 years, but there's a lot of development that's gone into this project. And so there's a lot of different assets that live in the project, and a lot of things are like, well, that's my favorite bush. It's like, well, that bush is 5 years old and it doesn't conform to anything. I hate it. But you got to keep the bush. You got to keep the bush. And so sometimes you need to fix things in order to keep it. And that's okay. There are ways to do it that are less painful than others. I happen to find myself in a place where we had about 200-ish different foliage assets that needed to have a lot of data applied to them. They needed normals modified. Normals are things that control if they're lighted in engine. They needed vertex data applied to them. And what I mean by that is information snuck into the mesh so that we can pull it out so that we don't have to load another texture. We had some things to do. I might add that as a side note to this process, all of the foliage that I worked on had to be impostered after the fact too. So it's even another step. But so lots of outsourcing at this project. We had like, I think 5 different, maybe 4 different outsourcing studios at one point. And that's when we were running fast. Not everybody complies to the standards, and not always are standards given when they're needed. Sometimes assets just get created. Lots of different types of assets for foliage. We've got the bushes, we've got trees, we've got hanging vines, things that are messy, all sorts of fun stuff. We found out the ship date at some point for the switch and had to make modifications to our shaders to deal with that deadline. And so then we needed to maybe modify some stuff after the fact. And then there's just a visual bar that had been defined and shown on trailers that we had to conform to. So there's a lot of things going into this. Some of the stuff that I'm talking about here, it really comes down to 2 different categories. It's the normals, and then it's the vertex color. What you're seeing here is vertex color applied to a mesh in Previewed and Unreal. We use the red channel in a mesh for the ambient occlusion that we bake into it, and we reference that for later. We use the green channel for the subsurface mesh. We needed a material, we needed foliage, we needed trees that were one draw, not several draws. We needed one material applied per tree. And what that means is I'm taking the green channel and I'm saying this is the part that can have subsurface values applied to it. The other stuff, treat it like it's opaque, treat it like it's a trunk. It's not going to glow. Please don't let it glow. The blue channel is kind of cool and a little bit, I don't know if it's unique, but we were very happy to have it. We do a lot of Fresnel. We grab the sun direction. And so I use the blue channel as a part of my mask stack on the foliage to get a prettier look. But it's kind of, if we had to do away with one of them, it'd probably be the bleach channels.
Use any channels for world position offset for wind and stuff?
No. And we've wanted to use the blue channel, the height, to give that control in the wind. And then now we have the green channel for the foliage, you kind of manipulate it more. But no, our wind will get love eventually. That we need our weather system to fully come in. It's not just wind. So anyways, what I'm showcasing here is on the right, we've got hardening normals. We've got sharp normals on this mesh, and it kind of looks not great. If you look on the left, it's a lot softer. It's got like a better visual when there's time of day movement applied to it. By the way, our game is time of day, and we have a nighttime and a daytime, and so we have a lot of lighting scenarios to contend with. Our meshes need to be as good as we can get them. That opens the discussion about PBR standards. I'm not going to do it. I'm going to note it. We're not talking about PBR today. We should talk about PBR sometime. So I took this perfectly wonderful mesh and I broke it for y'all. I applied terrible normals to it. It's a little bit easier to see it here than here, but that's bad normals for us. Those are good normals for us. And so we're going to walk through and talk about how we go about messing with this mesh. This is earlier I was talking about HDAs. This is a pipeline that I developed in HDA, which is a file from Houdini that you can drop into Unreal or other packages. And then you can have those settings saved on that HDA, on that actor within your Unreal level, so that if I were to modify this later on, I totally could rebake it and it's fine. If I need to roll back the revision of the asset that I output, I can just do that, rebake it, we're totally great. In this scenario, I'm going through the nitty gritty because I kind of want to show you all the behind the scenes and not just some HDA that looks all pretty. I'm going to have some addendums to it, but I just wanted to be able to have something to show you all. So let's do it. Usually in this graph, well, to preface, I didn't always do it as an HDA in Unreal. Sometimes I would have a tree that maybe was too legacy and I really needed to work on its normals, or the height gradient wasn't working very well, and I really had to finesse it. And so I always had Houdini input as well as the Unreal input. In Houdini, you need the Unreal input, object merge input at the top of your HDA, and so that's why that's there. But I would switch it to manual whenever I needed to. So right now, I'm going to separate the two. This is just a barth now. I'm going to give it some basic normals, some soft normals. You would do different things with it. Theoretically, in a perfect world, you might even, I don't know, bake the normals, but whatever. This is an example of all of the different options I had. It's kind of hard to see it in the back, I'm certain, but I had a lot of opportunities for control. Here we can soften the normals. That's controlled on, these are all controlled on a switch. You have the amount of control between the original normal and the softened normal as well for that blending mode, how much you want. We could take a blended or a smooth normal and then apply a dome to it and then blend those two normals together. You could just do a dome. You could do straight up normals. Up normals is a very common method of basically dealing with foliage and gains. And by the way, when I talk about normals, I'm realizing that this is a normal. This is the direction of a normal. A normal is the direction a vertex points effectively on a face. So what I'm trying to do is blend those to be less sharp. That's the goal here. This is me taking a dome, extending the dome to be larger than the object itself, and then I'm going to transfer that dome's manuals to see how many polygons there are. It's a very smooth mesh. That's going to get transitioned or applied to the mesh. You can see it was sharp here, and now it's soft. Very easy. There are lots of different ways to do this. If I were to redo this, I would try and create something that actually fits to the shape of the tree and then expands it, pushes out on its own normal of that and then deal with that. But for this instance, I really needed to convert 200 something assets. I need to do them right now. So here's what we got.
Sorry to interrupt.
Yeah, go ahead.
You could do that in Material in Unreal Engine, actually. Did you try that? See what it looked like?
We're trying to pull calculations off from Materials. Yeah, we've got to be as light as possible. It's actually, I'm very proud to say, like, our materials are incredibly optimized for a Switch. Like, we drop hundreds of calculations. It's really cool. We also are incredibly efficient in our packing of meshes. Our packing of textures. We drop full texture samples, full things. It's great. But yes, you can. And, on that note, the blue channel, the bounding box, you can totally do that in the material. It's just one more thing we're trying to avoid in our process. So this is an example of just, we have now taken these two different things, had their normals applied to them. We've merged them back together. we're going to move on and start playing with how we're going to apply vertex colors in. So just showing our normals are now nicer. Not necessarily perfect, but it's very nicer. We're going to start with red RGB, red. Basically, I'm going to clean the mesh kind of like what we did earlier to make sure that I don't have anything that I don't want. I'm going to then use something called masked by ambient occlusion. It's a specific node. In Houdini, when you're playing around with this stuff, you can basically, just like in Substance, just like in Unreal, you can basically type what you're thinking and you might find it.
Right.
Highly recommend. So at this point, I'm giving it a value. I'm basically doing a gradient, controlling it, and I'm giving it an actual attribute for it. And I'm going to promote that attribute to a color. I could get into the weeds with this. I'm going to avoid it. But there's a lot of different data types in Houdini, and you have to manage them. This is just an example of managing. From here, it's really simple. All we're going to do is say, hey, give me a full value of white for the foliage that I want to be subsurface. Give me a value of black for the stuff that I don't want to be subsurface. I'm going to merge those together. Those are good to go. Then finally, we're going to apply the blue channel, the height gradient, and that just starts with the bound. I'm going to do some things to kind of sort what we're dealing with. So you could, I'll group it, but I'll choose either to have the top or the bottom be the top or the bottom. You can swap which direction you want. In case of a vine, you might want the top to actually be, inverted effectively. I'm going to add points to it. I'm going to blast everything but those points. And so now we just have, you might not even be able to see it, but there's a little point here and a point there where the top of the box was. We're then going to create a line, just a line in between them. It's like a little line. I'm going to sort them. So whatever is the highest is going to be, number one. Whatever is the lowest is going to be 0. Then I have control on, how I'm going to apply the color to it. At this point, I'm using a resample node. This allows me to get a little bit more detail in that height gradient for when you're applying to it. Theoretically, you can move these around, but you could also move around on this curve. One cool thing about, Designer, but as well Houdini, they deal with a lot of curves, and you could add in like a bunch of points here and have some fun with it if you really wanted to do some cool stuff. I'm then going to take, we can see right here, it's black here, and it's getting white here due to that curve U attribute, a ramp attribute. And I'm going to transfer that onto the mesh. So we now see that it's nearly black down here, and it's hard to visualize it for this example, but it's basically white at the top. We're going to promote that. We're going to change the data type for it to a color, and then we're going to merge all this junk together. This is an attribute bot, which really is just one more way of blending things together. It's taking the 3 inputs, and I'm going to do something in there. So we're taking red to the front input, we're taking blue or G to the middle input, and then blue to the third input. And so within that actual geometry bob, I'm just separating out those inputs, applying them to a float vector, which is just effectively a color. And I'm just giving them the values and merging them out as one color. That's it. It's just to blend them together. It's nothing special. At this point, we're good. We're golden. We've made the thing on the left. It's got the vert colors that we need, and everybody's happy. It lends fast. I think that's it.